So we're talking about intersections of two planes today. And what we're going to be looking at is all the different types of solutions. This is the first section to the first part of the last section of chapter 8. And so what I'll do is I'll be drawing out all of my various planes here. So there are three types of solutions here. We have a line solution, and that's where the two planes actually intersect in a line, right? And so you can kind of remember these planes go on in each direction. So these would each go in that direction infinitely as far as you need. So you kind of imagine, two sheets of paper, and if they touch one another, they touch in a line, okay? The other scenario would be no solution, and that's where you've got, two planes and that sort of hover in a like before, they hover one above the other. And then you've got the other scenario where you've got your two planes, and they're actually the same plane here. Okay, so I'm going to kind of draw it like that. They're actually the same exact plane, but just sort of written slightly differently. All right, and so that's kind of the way that these guys work. Okay, and so let's start with this line solution here. Okay, for a line solution, it must be that, well, you've got your plane 1, all right, and you've got your plane 2. I'll call those plane 1 and plane 2, all right? They have an ABC, and the other one has an ABC as well. So they each have an A, B, and a C to their scalar equation. I'm going to do all of this in scalar equations, by the way. And so if you happen to get planes that are in vector form, go ahead and convert them out of vector form so that you can perform your calculations like I've demonstrated here. All right. So what you're going to want to do is take the ratios. Take the ratios of the normals. And so as you can kind of see here, each of these has a normal. So this guy's normal would be like that. This guy's normal would be like that, maybe. And you can kind of see that these two normals are not parallel, right? Whereas over here, in these other two scenarios, the normals are actually parallel. And so the nice thing about this technique is that all you do is you really just check the normals. If they're non-parallel, they guaranteed intersect in a line, okay? And so then what you would do is you would use the line finding technique. So use the line finding technique, which will be detailed below. I think it's actually going to be this one here. If you have no solution at all, then your normals are parallel, okay? And if you have infinite solutions, your normals are parallel. So the ratio of the A's, the B's, and the C's are equal. The difference between these two is that the ratios of your D's don't match up with your normal here, whereas here the ratio of your D values do match up. Okay, and so this is actually pretty nice. All you do is you take these ratios. If you get equals, A equals B, which equals C, and not equals D, you guarantee to have this, and you automatically just write no solution. Instead, here, if you get everything is equal, all ratios are equal, you don't have to do any work at that point. You just say there's an infinite number of solutions because the two planes are the same. So the nice thing about this little section is there's actually only one question that requires any actual work, okay? And that's this one here. All right, so let's go ahead and solve these examples down below, okay? So I'm going to go ahead and take this guy, and I'm going to write my two over 1 is equal to negative 1 over 1. Oh, it's not equal. Okay, so I automatically know I don't have this section or this section, and so I'm going to have to use the line finding technique. Okay, whereas over here, and I'll do that in a little while. Okay, over here, look at what we've got. 2 over 3 is equal to negative 6 over negative 9, which is also equal to 4 over 6, which is not equal to negative 7 over negative 2. And so therefore, we conclude that there is no solution. And we can even write that plane 1 is parallel to plane 2. Okay. Over here, plane, I guess we would write actually 3 and 4, plane 3 and plane 4, right? 3 and 4. Here, plane 5 and plane 6, I believe, are actually going to be equivalent to each other. And so what we're going to write here is, I'm just going to double check it. 1/3, is this equal to 1/3, which is equal to negative 2 over negative 6, which is equal to 2 over 6. Okay. So if all of those things are equal, then we have an infinite solutions. All right. Now, so that pretty much, over here we have a line solution. All right, so now the question is, well, how do I find that line solution? I'll use I'll use all of this area to find that line solution, okay? First thing I do is I take and I write my planes on top of each other. Okay, and then I write x plus y plus z equals 6 or equals 0, minus 6 equals 0. And what I'm going to do is I'm actually going to use the elimination technique. So I'm going to go ahead and add these planes to each other. Okay. You see this, and what's going to happen is I'm going to eliminate a variable. All right. You see this variable y? If I add this plane and this plane, I'm going to get 2x plus x, or I'm going to get 3x. And this is basically this is called plane 1, and this is plane 2. So I'm basically taking plane 1 plus plane 2. All right. And I'm writing it here. Then I'm going to get, what's a negative y plus a y? That's 0. All right. And then what's a z plus a z? It's 2z. So plus 2z. And minus 7 equals 0, because a 1 and a 6 become a 7. Okay. Now that's step 1. So you eliminate a variable. Step 1. You eliminate one variable. Doesn't matter which one. I eliminated the y's. Okay. Now, remember this. This was easy because the y1 was negative and 1 was positive. So I just had to add them. But if you have a scenario where it's like maybe I've got a 2 here, then what you can do is, remember, sometimes you can multiply one of the equations by 2, this one, for example, and you end up getting a negative 2y and then a positive 2y. But all of these other things would need to be multiplied by 2 as well. Okay, so be aware on that. Double check what's called the elimination process. All right, so now that I've got one variable eliminated, you see that I've got a single equation with one unknown value. Okay, so now in step 2, I'm going to set one remaining variable equal to t. All right, and I'm going to go ahead and write that down. So in my case, I'm going to go ahead and just say z equals t. So now I've got 3x plus 2t minus 7 equals 0. And then you solve for the remaining value, variable. All right, that's supposed to be an E here. All right, solve for the remaining variable. Okay, so I'm going to go ahead and I'm going to solve for x. So if I want to solve for x, I get x equals a negative 2t plus 7. All of that is over 3. I just went ahead and solved for x in this formula. Okay, now you can kind of take a look at what you've got. You've got this equation and you've got this equation here. Both of these are, this is x, this is z in terms of t, and this is x in terms of t, is what it's called. Now, all I need is y in terms of t, right? So now what you do is in the last step here is you plug these two things into one of your original plane, right? So plug the two formulas into a plane. I'm going to take plane 2 here, so I'm going to write that down. Plane 2. And I'm going to write x, which is negative 2t plus 7 over 3, plus y, plus z, but remember z is t, minus 6 equals 0. And now, in the last step, you now solve for, having trouble here today, solve for the remaining variable. Remaining variable. All right. So that's step 1, step 2, step 3, step 4, and step 5. Right. So now my remaining variable is y. I'm going to go ahead and solve for it. So let me go ahead and write y is equal to a 6 minus t, so 6 minus t minus a negative 2t plus 7 over 3. And now if you look closely at this guy here, you can see that this is going to be solvable in terms of, I can simplify it and I can get this, okay? Now, I'm going to get y equals, looks like I've got 6 minus t plus 2t over 3 minus 7 over 3. I'm going to have to get some common denominators here. So my common denominator is 3, so I'll multiply this by 3 over 3. And then I'll multiply this guy by 3 over 3 as well, giving me an 18 here. Okay, so now I'm basically doing 18 minus 7. That's going to be 11 thirds. And then a negative 3 thirds t plus 2 thirds t is going to be a negative 1 third t. So this is equal to a negative 1 third of a t minus, what did I say, 11 thirds, okay? And that's my y, okay? My x was this, and my z was this, okay? So now I've got a line where my x is a negative 2t plus 7 over 3, right? So let's put each one. My y is a negative t over 3 minus 11 thirds, and my z is t. Turns out this is a line, and that line is actually on both plane 1 and plane 2, okay? Remember, we have a line solution, so that would be like, for example, this line right here, right there, all right? remember, when two planes intersect, they intersect. The location where they intersect is not a point, it's a full-on line. So that's why our answer actually has to be a line, and that's why here I put z equal to t, okay? And so we were attempting to find the line solution, and a line in 3 dimensions needs a parameter, okay? So there's our line there, all right? Now, if you went ahead and plug this in to both of these two lines, you would find that you get an infinite number of solutions, okay? So that's kind of cool, all right? Matter of fact, how would you plug it in? Take this thing right here, this line, and plug it into line plane 1, for example. What do I mean by plug it in? Well, plane 1 is this, 2x minus y plus z minus 1 equals 0. This is a line, so I'm going to write 2x minus y plus z minus 1 equals 0. I'm going to go ahead and plug in my x, y, and z, right? This x, this y, and this z. This is the answer. You don't have to do this part, by the way. In a question, we've already found the answer. I'm just showing you that the answer is correct, meaning that this line here is on this plane. So what I do is I plug in a negative 2t plus, I'm not going to have space here. I'm going to open that up a little bit more. Negative 2t plus 7, and this is each over 3, minus y, but y, remember, is a negative, is this, okay? So a negative t over 3 minus 11 thirds, okay? And plus z, so plus t minus 1. So then you might be saying, well, how do I know that what all this is, okay? Well, what I'm going to do is I'm going to simplify this and see what happens here, okay? Let's see here. So this 2 distributes in like this. And so I'm going to get a negative 4t over 3 plus 14 over 3 minus or plus t over 3 and plus 11 thirds plus a 3t over 3 minus 3 over 3. I went ahead and with these two guys, I went ahead and got a common denominator of 3 because I know I'm just going to have to look at all these guys are in 3s here, right? So now, taking a look at this, anything with a t in it should combine, okay? And anything, so if you look closely, I've got a negative 4t plus t. Oh, shoot, what happened there? Negative 4t plus 3 plus 3. All the t's go away, so I get 0. Interesting. So I get 0t. What's 14 thirds plus 11 thirds, right? Wait. Hang on a second. I should be getting a 0 here. Hold on. Maybe I am getting a 0 here. 14 thirds. What's 11 and 3 here? This is supposed to be, I think this 11 is supposed to be negative here. Because I'm supposed to also get a 0 here, plus 0 equals 0, okay? And look, you see this, if this were a negative 11, I would get negative 11 minus 3, which would end up being a negative 14 thirds plus a positive 14 thirds, which ends up being 0 equals 0, which is always true, which basically means regardless of your t value, or no matter when I say regardless of your t value, I actually am really saying, every point on the line is on our said plane. Okay, so let's go investigate and see why I'm supposed to be getting a negative 11 and I did not. Where does this 11 come from? Here's my negative 11, right? And there's the issue. It's 18 minus 7. You see that? 18 minus 7 is supposed to be a positive 11, which is right here, which makes this positive, which makes that positive, which then distributes that negative in and makes it a negative. Sorry. Negative 11, which means 0 equals 0. Okay? Sorry about that mix up there. It's always nice to make a mistake and go back and find it. All right. So there we have it. Intersections of two planes.